Assalamualaikum and good day to all. Today Group 1 will present assignment 2 which is related to fuel requirement, coal ultimate analysis, heating value or calorific value. This group have 5 members. Start with Shamsul, Shah Zihong, Aizat, Patricia and Aidil. So this is the topic that will be discussed.
So now we start with fuel, which is simply a combustible substance. We will focus on hydrocarbon fuel, which is divided into three: liquid hydrocarbon fuel, gaseous hydrocarbon fuel, and solid fuel. The first is liquid hydrocarbon fuel, which is processed by distilling and cracking crude oil. The composition used are usually given in terms of mass fraction. Example for this liquid hydrocarbon fuel are gasoline, diesel fuel, kerosene or other types of fuel oil. The second is gaseous hydrocarbon fuel. In this fuel is chemically produced or derived from natural gas well. The composition of gaseous fuel are usually given in terms of mole fraction. This gaseous hydrocarbon fuel can be synthesized from coal, oil shale and tar sand. Last but not least is a solid fuel. Mining location effect is composition considerably. Usually composition from solid fuel is on a mass basis. The example is coal.
Assalamualaikum. My name is Aidil Farhan. My part is about fuel requirements. There are several factors that need to consider in choosing fuels, such as heating value. Fuel that has high heating and good gross calorific value need to be considered. Next, fuel that need to use as combustion should be cheaper, and the fuel that being used must have high combustion efficiency, meaning that the ratio of heat released by the fuel must higher than the input by the fuel. After that, minimum ash. It should have low ash content since the presence of ash reduces the heating value of fuels. Lastly, handling and storage fuels. The fuel need to store carefully to avoid contamination. Each type of fuel require different ways to store. For example, the importance of cold storage. Main motive of cold storage is that to minimize oxidation of coal, spontaneous combustion, self-heating of coal, and increases in moisture. The difference between high heating value and low heating value. By the definition, high heating value, amount of heat released by a specific quantity initially at 35 degrees C. Once it is combusted and the products have returned to a temperature of 35 degrees C. For low heating value, amount of heat released by the combustion a specific quantity of a fuel and returning the temperature of the combustion product to 150 degrees C. For the occurrence, by bringing all the product of combustion back to the original pre-combustion temperature while allowing any produced vapor to condense. For low heating value, by subtracting the heat of vaporization of water from the high heating value. High heating value for phase of water is liquid, and for low heating value is water. The difference between gross calorific value aka high heating value and net calorific value aka low heating value. By the definition, gross calorific value defined is the amount of heat produced as a result of the complete combustion of a unit volume of the substance. And for net is value is the subtraction of the heat of vaporization of water from the high heating value. Amount of heat of the gross calorific value is that created when the water converted into water vapor back to liquid state. For the net calorific value is the amount of heat created when water converted into water vapor upon combustion of a material. And as for measurement for the gross calorific value by experimental methods, and for net calorific value is calculation using gross calorific value, the oxygen, nitrogen and hydrogen content of the sample.
Okay, next is the calculation related to fuel. The question is, a compound contains 92.3% carbon and 7.7% hydrogen. The molecule of compound is 39 times heavier than the hydrogen molecule. The molecular formula of the compound is, so that's the question. So to solve this problem, there are three simple steps that need to be followed. The first is to find the empirical formula. The second step is calculate the molar mass, and the last is to calculate the value of N. So the calculation is shown in the slide.
Hi, my name is Aizat and I'm going to explain about coal. Coal is a combustible black or brownish black sedimentary rock formed as rock strata called coal seams. Coal is mostly carbon with variable amounts of other elements, mostly hydrogen, sulfur, oxygen, and nitrogen. Coal can be burned for fuel and used to generate electricity. It is composed mostly of carbon and hydrocarbons, which contain energy that can be released through combustion. Coal exists in underground formation called coal seams or coal beds. A coal seam can be as thick as 30 meters and stretch 1,500 kilometers. Next is the pros and cons of using coal as fuel. The first pros of using coal as fuel is it is available in an abundance. It means that coal are available all year round as long as coal mining doesn't stop. Next, cost of using coal as fuel is lower than other option. Since coal is always available, the cost is not expensive. Coal is always available, making it reliable source of fuel. However, using coal also comes with some disadvantages. First, coal mining destroys natural habitat. The mining destroys the ecosystem around the mines since coal mines use heavy machinery. Next is coal as fuel means relies on a finite resource. Even though coal is available in an abundance, continuous mining will someday cause depletion of coal supply. Last one is produce deadly gases and pollution. Burning of coal to create energy also produce dangerous gas and pollution. Plus, the heavy machinery that are used to mine coal also cause pollution.
Hello, my name is Cha Ji Hong. Now I'm going to present the coal ultimate analysis. So coal ultimate analysis is a process of determining different chemical elements present in coal. So it gets more comprehensive result compared to the proximate analysis process. So this analysis is to determine the elemental composition of coal samples such as testing moisture, ash, carbon, hydrogen, nitrogen, sulfur, and oxygen content. So below is the equation that is 100% by mass is sum of the carbon, hydrogen, oxygen, nitrogen, sulfur, moisture, and ash. So if there is no moisture or ash in coal sample, we can use dry and ash-free analysis to obtain other chemical components. So below is the rest of the component is equal to 100% minus to the percent of moisture and ash. So for example, a sample of coal has the following molar mass. Carbon is 77%, hydrogen is 3.5%, oxygen is 4.5%, nitrogen is 1.8%, sulfur is 0.7%, moisture is 6%, and ash is 6.5%. So we need to calculate the coal ultimate analysis and mass percent. So first, from the molar mass table, we get the molar mass for each element. So below is the periodic table of the element, and we find the molar mass for each element. And this is shown at the right side of the table. Next, we are going to convert to the mass analysis. So for example, a 77% of carbon is multiple to its molar mass, which is about 12, and we get the mass analysis is 9.24 for carbon, and the rest will calculated as well. And next, we will sum out all the mass analysis to get the total mass of the product, which is 24.973 kg. So the last is to calculate the mass percent of each element. So for example, 9.24 kg of carbon is divided by the total mass of the product, 24.937, and then multiple 100% and we get 36% of carbon in coal, and this is the mass percent for the carbon. and the rest is shown in the table.
Assalamualaikum and hi. Today I will present about calorific value and some simple solution. Um, First is the definition of calorific value or heating value. Uh, it is the quantity of heat energy contained in fuel as measured by the complete combustion of a specified quantity. So SI unit for calorific value in fuel in phase solid or liquid is kilojoule per kilogram, and SI unit for calorific value in gaseous fuel is kilojoule per m power of 3. So this is the formula of calorific value. It's named Dulong and Petit formula. So first formula to find HHV, which is higher heating value. So it is equal to 33.83 C plus 144.45 time hash minus O over 8 plus 9.38 S time 10 power of 3 in kilojoule per kilogram. So the C is the carbon, H is the hydrogen, O is oxygen, and S is sulfur. Next, to find LHV, which is lower heating value, is equal to HHV minus MW times HFG. So what is the MW? MW is the mass of water vapor. So this slide show the equation of MW, which is equal to M plus 9H plus MAW. So M is a moisture of the coal, H is a hydrogen, MA is the actual amount of air supplied per kilogram of the coal, and the W is a specific humidity of atmospheric air. So by assuming the latent heat of evaporation or FG at the partial pressure of water vapor in the combustion product as 2442.3 kilojoule per kilogram. Next, if the moisture M or the water vapor of atmospheric air MAW in the supply air both are zero, then the equation of LHV can be expressed as LHV equal to HHV minus 2442.3 times 9H. Next is example calculation of calorific value or heating value. So the question is, a sample of coal has the following composition by mass. Carbon is 75%, hydrogen is 6%, oxygen is 8%, nitrogen is 2.5%, sulfur is 1.5%, and ash is 7%. So calculate the higher and lower calorific value of fuel per kilogram. From the data given, we can solve this equation. So for first step, we want to find the HHV or higher heating value by using the Dulong and Petit formula. We include that the data in the equation. For example, the value of C carbon, H hydrogen, O oxygen, and S sulfur. So next, after we include, we solve all of it, and finally we get the answer or HHV, which is 32,735.7 kilojoule per kilogram. Okay, next we want to find the lower heating value or LHV. Um, so from the formula, we include the value of HHV that we get from first step, and the value of H, which is hydrogen. So after we include all of it, we solve uh, this equation, and lastly we got the LHV value, which is 31,416.86 kilojoule per kilogram. So that's all from me for the example uh, calculation. Thank you.